evaluate the area of this region using a Riemann sum for n equals 4 subintervals, and then it should tell you whether using a right, a left, or a midpoint sum. So let's do 4 rectangles or 4 subintervals and a right Riemann sum here. Going back to this, I forgot that I had never used this, but basically if I wanted to graph this line by plotting points as opposed to just drawing the line, I could substitute 0 in for x and I'd get 4. If I plug 1 in, I'll get 2. 2 gives me 0. 3 gives me -2. And 4 gives me -4. So these are all just points that we're plotting in order to graph this line. So you can do it either way. Anyway, using the Riemann sum, remember this is only going to be an approximation. In order to calculate it precisely, I would need an infinite number of subintervals, and I definitely don't have that here. So this will be an approximation. And when we do the geometry, we'll get an exact answer, so we can sort of compare. All right, so first of all, formula. So I'm creating a sum, a Riemann sum, starting with k equals 1 all the way up to 4, because that is my n value. And I need to take my grid points, which I will calculate in a second, and I need to evaluate them by plugging them into my function x in order to get the height of every single rectangle, and then I need to multiply that by the base of every single rectangle, which is delta x. So let's calculate some things to start. Delta x, the length of each subinterval. So I'm going from 0 to 4, that's my total interval, and then I want 4 rectangles. So if I take 4 minus 0 and divide it by 4, I'll get a delta x of 1, meaning every single partition or every single subinterval is going to have a length of 1, and every single rectangle is going to have a base of 1. All right, let's figure out what this will be. So all of my grid points are going to be calculated based on whether it's a left, right, or midpoint Riemann sum. And so in this case, we are doing a right Riemann sum. So if I have these intervals, 0 to 1, 1 to 2, 2 to 3, and 3 to 4. If I have these intervals, I want to use the right-hand endpoint from every interval in order to calculate my height. So in the first rectangle, the height of my rectangle is going to be f of 1. So I'm going to be calculating the area of that rectangle right there. My second grid point is going to be 2. So f of 2 is going to be the height. And so in this case, that just gives me a height of 0, and we'll see that calculation in a second. In the third region, my right endpoint is 3. So that gives me a height here, and a rectangle that looks like that. And then my final right endpoint is 4, which gives me a rectangle that looks like that. So just looking at it overall, I have 4 regions, except this second region ends up being an area of 0. And it looks like I've got 2 on the negative side and 1 on the positive side. So I'm hoping to see an answer of negative, a negative net area here. That would be the only thing that makes sense. So let's go ahead and do these calculations in order to find the height of every rectangle. So the f function here is 4 minus 2x. And my delta x we calculated to be 1. So let's run through. If we let k equal 1, which is our first grid point, plug 1 in here, and we find the height of that rectangle to be 2. Take 2 and multiply it by 1. Or add up all of the heights first and then take that answer and multiply it by a base of 1. Alright, so my first height is 2. My second height is when k equals 2, so plug 2 into my function, and I get 0 for my second height. My third rectangle, k equals 3, I get negative 2. And my fourth, let k equal 4, and I get negative 4. So these are the heights of all 4 of my rectangles, and if I add them all together, I'm going to get negative 4, multiply it by a base of 1, and my net area is approximately negative 4. So that makes sense with what I expected based on my graph. I have more area that is below the x-axis than above, so it makes sense that I get a negative. Again, this is not the exact answer. This is only approximation based on 4 regions. Had I split this up into 100 regions, my answer would be much more accurate. Also keep in mind that if you use the left endpoints or if you use the midpoints, that you do get different answers, different approximations. Alright, let's take that same example and let's calculate the area exactly by using geometry. So I'm going to draw this again. It's especially important for geometry that you have a really good, accurate picture. So my graph, again, was bounded by the interval from 0 to 4. And if I graph it, I have the point 0, 4, the point 1, 2, the point 2, 0, the point 3, negative 2, and 4, negative 4. So once again, my graph looks like this, and I have these 2 triangular regions. So using geometry, I want to look for geometric shapes that I know how to find the area of. So for a rectangle, I know the area is base times height. For a triangle, I know it's base times height divided by 2. For a trapezoid, just in case you've forgotten, I'm going to take 1/2 the height times the sum of the 2 parallel bases. Certainly we could have a circle as an option, although it wouldn't be a function, so that's a problem. But perhaps a semicircle. Pi r squared divided by 2. So just a couple of things to have in your back pocket there in terms of area formulas. Here we've got 2 sections or 2 regions, and I'm going to call one of them A and the other one B. So region A is above the x-axis, which means that its area is going to be positive. It's a right triangle, which is good news because that's very easy to find the area of. Its height is 4 units. Its base is 2 units. So if I multiply those and divide by 2, I get an area of 4. Region B is below the x-axis, so that tells me its area should be written as a negative. Now, when I actually calculate the area, I'll get a positive, but I need to make it negative to represent the fact that it's below the x-axis. I drew that weird. Let me try again. it's oriented in this way. So, get rid of that there. Its base is 1, let's see, that's supposed to cross exactly at 2. Its base is 2, its height is 4, and its area is exactly the same, 4. So if I take my two regions and I put them together, my net area is going to be 4 plus negative 4, which turns out to be 0. So the actual exact answer for the integral of 4 minus 2x with respect to x from 0 to 4, the correct exact answer is 0. And again, with the Riemann sum, we were able to approximate that, and it wasn't really that close. So the actual answer is 0. The reason that that happens is because of the nice symmetry that happens where these two triangles are equal in area, and so they cancel each other out, one being above and one being below. Let me do one more example of geometry for you. So let's say we want to evaluate the function negative absolute value of x with respect to x from negative 1 to 2. So we want to evaluate using geometry. So let's get a graph. When you're talking about using geometry, you need to have that graph. Alright, so we have the absolute value of x, and that graph looks like this, except it's being flipped upside down. And so the graph would look like this. Let's bound it though correctly by the interval. So here's negative 1, which means it's going to be bounded on the left to create this region. And then on the right, it goes to 2, which will bound it on this side and create this region. So now we have two triangles, two right triangles that are both below the x-axis, which means that when I evaluate this, I'm going to get a negative answer representing my net area. So once again, let's separate into two regions that I can find the area of individually and then add them together. So A is a right triangle, its base is 1, its height is 1. Divide those by 2 and I get an area of 1/2, except it has to be negative because it's below the x-axis. In this second right triangle, I have a base of 2. I have a height of 2, and by the way, if you didn't calculate that point right there, I did it kind of quickly. If you plug 2 into this function, the absolute value of 2 is 2, and then make it negative. So this goes down to negative 2, which means the height of the triangle is also negative 2. Notice I didn't put the negative in there, and that's just because heights really aren't negative, but the region itself has a negative area because it's below the x-axis, but it certainly wouldn't be wrong if you put a negative in there. So the area of that region, 2 times 2 divided by 2, gives me a 2, and it's also negative. So my net area is going to be negative 1/2 plus negative 2, which is negative 2.5. Negative 2.5, negative 5/2, any way you want to express negative 2.5.